In an earlier video, which I'll link to in the description below and in a link floating over my head, we determined that the delta H for this reaction is equal to this number right here, and the delta S for this reaction is equal to this number right here, positive 13.74 joules per mole Kelvin. Now in this question, we're asked to take that information and use it to determine delta G. How do we do that? By using the equation right here, that delta G is equal to delta H minus T delta S. And I guess I'll put the little degree sign here for standard state conditions, okay? There's one problem, however. Our units don't match. Our units for delta H were kilojoules per mole, but our units for delta S are joules per mole Kelvin. So we need to do something about that joule-kilojoule issue. Because the multiple choice lineup in this question is given to us with units of kilojoules next to everything, or kilojoules per mole, I should say, I'm going to try and convert these joules into kilojoules so that I have matching or closer to matching units. The way I do that is take this answer right here, this value for delta S, and I convert the joules to kilojoules by putting joules in the denominator, kilojoules in the numerator using dimensional analysis. Kilojoules, I remember, is the big value, so I put the small number next to it. Joules, by comparison, is smaller, so I put the big number next to it. Divide 13.74 by 1,000, you convert it into this term. So the delta S written in these units is this number right here in kilojoules mole per Kelvin, or kilojoules per mole. Does that make sense okay? Now that we have all of that, we can take our delta H value and our delta S value, as well as our temperature, which is not given to us in this original question's wording, but is provided in the previous question as 298 kelvins. I insert them into their respective locations and then plug and chug on my calculator. So I've got my negative 537.2. I put that in there for delta H. I subtract from it my temperature of 298 kelvins, insert it in there for T, and my delta S right here, right there, okay? You'll notice that my kelvins right here cancel each other out. So I'm left with final units of kilojoules per mole. And when I plug and chug in my calculator and round, I end up getting a final answer of negative 541 kilojoules per mole as the answer for delta G for this reaction. Because it's negative, it is spontaneous. And as you can see, that answer lines up with option C.